Let C be a positively oriented simple closed curve containing the point z0, and we would like to compute the integral along C of 1 over z minus z0 to the nth power dz, where n is an integer bigger than 2. So we have some point z0, and we have some positively oriented simple closed curve containing the point z0. So the orientation is in this direction. As we traverse the simple closed curve, the interior is on the left. That's the positive orientation. So we don't know very much about this curve, just that it's a simple closed curve, which means it has an initial point and a terminal point that coincide, and it doesn't cross itself in any other place. And z0 is interior to it. So we have the deformation of contour theorem, which tells us that we can replace this arbitrary contour with a nice circle as long as the function is analytic on both curves and in between them. Well, the only place this function is not analytic is at z0 itself. So if we take a circle with center at z0 and some positive radius, then we can use the deformation of contour theorem to replace C with our circle. This function is analytic on this circle, and in between the circle and the arbitrary simple closed curve C, because again, the only point where this function is not analytic is the center of the circle, z0. Now, the size of the circle will depend on the contour, but because z0 is on the interior, is in the interior of the contour, that means that there exists some radius, it could be very tiny, such that this circle is completely contained inside of C. Okay, so this integral is equal to the integral around the circle center z0 radius r. So we could replace C with this nice friendly circle. And now we can compute this integral by just parametrizing the circle. So z will equal gamma of t, which equals z0 plus r e to the it. We have positive orientation, center z0 radius r, and t, the real variable t, goes from 0 to 2 pi. So z minus z0 to the n is going to equal r e to the it to the n. And that's f of gamma. Well, 1 over that would be f of gamma of t, and gamma prime of t is ir e to the it. So this integral is equal to the integral from 0 to 2 pi of 1 over, we replace f of z with f of gamma of t. So instead of z0, z minus z0 to the n, we'll put this. So it's 1 over, and we'll distribute the n here. R to the n, e to the int, and then times gamma prime, which is ir e to the it. So this, we could take out I and R on the top and R to the N on the bottom. And we're left with E to the IT over E to the INT. This can simplify, but I'll worry about that later. Now this one we need to simplify, the integrand. So subtract exponents. It minus int is it times 1 minus n. So e to the power it times 1 minus n. Now we'll compute this integral. We have IR over R to the n, or just I over R to the n minus 1. And then we have, now the antiderivative here is e to the it times 1 minus n divided by I times 1 minus n. And we have to plug in 0 and 2 pi. So this I and that I cancel. So we have R over R to the n, and we have this 1 minus n. And now we have to plug 0 and 2 pi into this function for t. And this is going to give us 0. So we have this number in the front. And then this is e to the 2 pi I times 1 minus n minus, and we put 0 here, e to the 0. And this is e to the 2k pi, where k is this integer here, and e to the 2k pi I is 1, and then 1 minus 1 is 0. So this is 0. So the integral is equal to 0, which is good because this constant in the front depends on r, and our answer intuitively shouldn't depend on r, because we should be able to pick this circle or a smaller circle, or maybe a slightly larger circle, and we should get the same answer, because the deformation of contour theorem says that the integral around this positively oriented contour is equal to the integral around any other positively oriented simple closed curve, as long as the function that you're integrating has the proper analyticity properties. It needs to be analytic on the curves and in the region in between them. So the size of the circle should not affect the answer. And here we did have some expression involving r, but the rest was 0, so this part didn't matter.